The concrete thickness gauges come in a Pelican case with foam padding on the inside to protect the components that are part of the systems. Now the following components are included in the concrete thickness gauge. CTG test gauge, a telescoping extender pole, the test head with extender feet, a power adapter for 110 or 220 volts alternating current, a software installation CD, and the PC notebook serial cable for data download, and a user's manual. I take pride and pleasure in introducing you to how to use our concrete thickness gauge. This impact echo-based device is the world's easiest to use, fastest, point-by-point impact echo test system out there. It will test the thickness of concrete pavements, slabs, tunnel linings, so you can predict these without having to drill or core. So now, as we first get the gauge, it needs to be charged. So this is the AC power supply and adapter. It charges and it will power the gauge should the batteries be run down. Now the battery life is very good, from 10 to 16 or more hours. 10 hours with the backlight on, and even longer, of course, with it off. But if you do need to power it when it's dead, and you have a source of 110 or 220 volt alternating current, you can plug in here, plug this in your wall, and it will power the gauge. Now, when you first turn the gauge on by pushing this button, it will come up. You will then connect it also here to the impact echo test head. Right here is the test head with the displacement transducer and solenoid impactor for what we call thin mode, from nominally 3.5 to 24 inches, meaning about 9 centimeters to around 60 centimeters in thickness. For thicker concrete, you take a small hammer and tap next to it in thick mode. And then you can go out to 1.5 to 2 meters, 5 to more than 6 feet. So as I step around to operate the gauge, it says, enter a design thickness. Well, we're going to demonstrate it on a 15 centimeter or 6-inch tall cylinder today. So we're going to enter 15. Enter in the lower right. It says it's going to test out to 20 centimeters in thin mode with the solenoid. So we've gotten it ready. We press 1 to test. It's a red button. 0 and 3 will also do the function of 1 because they're also red buttons. Now it gave us a result of 14.3 centimeters, and you might have noticed the low battery light flashed. We wanted to show you that when it starts to get low, that will flash at you, and then you don't have so much more time left. So now we will save this, maybe 15 minutes once you see a low battery light. We can save that result that says 14.3 centimeters, and it will be saved in this case as file 112, push a 1 to exit. You would make a note of your location of the test as file 112. So that's the basics of the gauge. We're going to quickly repeat that test. It's a good idea to check repeatability. It says 14.3 centimeters again. If I hit the English metric switch, it now says 5.62 inches. So I can save that. It's a good idea to see, maybe you do 2 tests. The first test, you look at the result. The second test, you save it if it repeats similar to the first test. You've gotten good data. So the next step is to point out that you can use it with our extension pole. This goes right on here. You use a pin to push it into the handle and connect it for testing overhead or down on a slab or pavement. And it just adjusts in length. It'll go out to about 5 feet or 1.5 meters. So that's the extension pole for reaching up and testing. One other thing to point out is that when you're through with your tests, you can download data. And that's through a 9-pin serial that goes into your notebook or PC serial port, plugs it in, and there's a download data mode in the gauge. If you're also testing overhead or above, you might want to add these extender legs. These just screw right in, going into the back end for the other normal legs that are here, and they will give you a little more stability when testing on a flat slab or reaching up overhead on a ceiling or on a wall, say. Another component that we'll mention is part of our new gauge, and this impact echo test head has an extra feature for our new gauge, which is a CTG1 TF for thickness plus flaws, SW for surface wave. This puts the surface wave in there so that you can measure the speed from this displacement transducer to this one by tapping here. From that surface wave velocity, we divide that by a factor typically on the order of 0.53 to correct for Poisson's ratio and some elastic wave considerations to compressional wave velocity or the impact echo velocity. So that's a very simple thing to add and completely minimizes the need for calibration on a known thickness for more precision in sound velocity. So now what we'll do is look at some of the other features of the gauge. It says press 1 to test as we've done, 2 for calibration or data transfer, 9 for high resolution mode, 6 to switch to thick mode where you use a small 4-ounce or quarter-pound, 100-gram hammer, say, to test thicker concrete of greater than 50 to 60 centimeters, around 2 feet and greater, out to maybe 5 to 6 feet, about 1.5 meters. So we will say 2 to look at options under option 2. These options are thickness calibration, if you know the thickness from coring or drilling, to do a test, get a speed of sound for the impact echo test, and you're calibrated based on a core hole, a drill hole, or a testing at the edge of an exposed slab, say. The other option is velocity calibration. If you know a velocity of sound from averaging velocities from a number of tests at core holes or drill holes, or just putting in a velocity because you know the concrete from previous test experience. Now the maximum thickness setting, you can reset that without turning the gauge on and off. You can set it to an absolute maximum. And then there are options to download or recall data and set the internal clock, which tells you the time, the date, the velocity, and other information that comes out of a concrete thickness summary table that's transferred via the serial port. So if we look at a thickness calibration, we know that this is about 15 centimeters in height, or 6 inches. In this case, we're in the English mode, so we're going to enter 6 inches. After that is entered, it says press fire. Any of the red buttons will fire the gauge. And we got a velocity of 12,816 feet per second with a Q of 9. The Q value is a quality indicator. The higher the number, the sharper the peak. A Q of 0 or 1 would be very low. A Q of 3 or 4 is not unusual for a quality factor on slabs on ground, which are rougher on the bottom and a less sharp peak. But the Q of 9 is typical, 8 to 9 for structural concrete with sharp boundaries of reflection. So now we can save that. You could repeat it immediately with that new velocity. And we got 6 inches exactly. So we could save that if we wanted to as well, but that shows a good calibration by repeating it without moving the gauge. Now if we did that test in a metric sense, we would hit the English metric button here. We can do the test, and it shows 15.2 centimeters. We hit the English metric switch, 6 inches with a Q of 9. If you don't want to save it, you can simply exit it. If you do save it, it tells you the file number again, 116. You make a note of the location. So exiting out of this mode, looking at the other options quickly, under 2, there's a velocity calibration. Right now, we, from our calibration, came up with 3,906 meters per second. If you had a different number from previous testing, you could enter 3,800. The gauge default is 3,657 meters per second, and which is 12,000 feet per second. But you can calibrate, as we've just shown, on the known concrete. So we enter that. Now if we repeated the test, we're going to get a slightly different number because it's a slower velocity. Depth equals velocity divided by twice the resonant frequency of the echo. It's saying about 14.8 centimeters. The other options, maximum thickness setting is very simple under option 2. You just enter a new maximum thickness. Download recall options can do several things. Recall the data, you can put a file number in it, enter 1. You can clear the data entirely if you want to clear the memory out, but then you lose all your data if you've not downloaded it already. You can set the clock for the date, the time of the measurements to be accurate, and you can download it through the serial port as we've discussed. So in this case, if we just said recall data, and we asked for, say, file 112, this shows 14.3 centimeters. So that's the basics of operating our concrete thickness gauge. I think you'll agree it's very fast and easy to operate, very ruggedized. I want to show one final thing about what's happening during the test in thin mode. As I push this, it is tapping the concrete, and you can see that here as I push it right there. You see the solenoid tapping and the displacement transducer that's here to pick up the echo. So one more time, there is our concrete thickness gauge. This concludes the demonstration of Olson Instruments' concrete thickness gauge. We have 4 models of concrete thickness gauges from which you can choose. The CTG1T model for thickness, the CTG1TF model for thickness plus flaws, the CTG1SW model for surface wave velocity measurement, and the CTG1 thin model for thin concrete down to 2 inches or 50 millimeters. For more information on the products of Olson Instruments or the services of Olson Engineering, please visit us on the web. I want to thank you for your time, attention, and interest in Olson Instruments products.